Hello, this is mathjazz from Almost Cool. I was sent this problem, and I'd like to solve it for you. It goes like this. Maddie is training her white rabbit Ghost to climb a flight of 10 steps. Ghost can only hop up 1 or 2 steps each time. He never hops down, only up. How many different ways can Ghost hop up the flight of 10 steps? Okay, so this problem is a combinatorics problem. That means basically we're counting a lot of things. So what we're counting here is the number of ways that Ghost can hop up. When we do a combinatorics problem, the important thing is figuring out a way to keep track of everything you've counted so that you don't count the same thing too many times. Also, so you don't skip anything. So what I'm going to do is I'm going to use some notation that'll help me to keep track of things. I'm going to use a dot for a single jump and dash for a double jump. I am also going to notice that if I have, let's say I have n single jumps, so some number of single jumps, let's say this example has 3, and a double jump, there are n plus 1 ways to arrange these jumps. So I can go, for example, with 3 single jumps and 1 double jump, I can go 1, 2, 3, 5, or I can go 1, 2, 4, 5, or I can go 1, 3, 4, 5, or I can go 2, 3, 4, 5. Notice there are 4 ways to do it. These are the only 4 ways I can arrange these jumps. And it is 1 more than the number of single jumps that I have. This works the other way too. If I had 3 double jumps and a single jump, then I could go 2, 4, 6, 7, or I could go 2, 4, 5, 7, or I could go 2, 3, 5, 7, or I can go 1, 3, 5, 7. So if I have 1 jump of one type and n jumps of another type, there are n plus 1 ways of arranging those. I'm going to use this to help me count everything so I don't have to write down all of the possible combinations. So the other thing I'm going to do is I'm going to start counting. I'm going to count all of the ways to get up that have the same number of double jumps together. So for example, there's only 1 way to get up with 0 double jumps. That's 10 single jumps, okay? So there's only 1 way to do that. And I'll write it out here just for completion's sake. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 single jumps. That's the only case that works with 0 double jumps. So with 1 double jump, there will be, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's how to get up all 10 stairs. Now notice there's 1 double jump and 8 single jumps. So that's going to be 9 possible ways to do 1 double jump. So 1 way to do 0 double jumps, 9 ways to do 1 double jump. And then let's do 5 now, just to get that out of the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is only 1 way to arrange those. And let's try 4, because 4 shouldn't be too bad either, I don't think. So we have 4 double jumps gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is maybe a little bit harder than the 1 case, but it shouldn't be too bad. Okay, so I'm going to do the 4 case like so. I have my initial segment is going to be my first 3 double jumps, and my end segment is going to be my last double jump and whatever single jumps are there. So this is all of my double jumps came first, and then my single jumps. So let me rephrase that. This is the first 3 jumps I take are double jumps, and then I take the rest of my jumps. There are going to be, since there's 1 double jump and 2 single jumps, there are 3 ways to rearrange this tail So this is what I'm going to call the start. The first jumps I make are the start, and this is going to be my tail. It's the last jumps that I make. The last jumps that I make will always be the last double jump that I jump and whatever single jumps come near it. So, for example, in this, if I were to write this out completely, I'd go double, 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 single, single, and double, 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 single, double. Notice there are 3 ways to arrange these last 3 jumps: double first, double middle, double last. That gives us all 3 of them. Okay, so that might have sounded a little bit pedantic, but I just want to make it clear what I'm about to do. So there are 3 ways to arrange these. So then I can do, instead of I can do double, double, single, double, and then have a tail that's a double and a single. There are 2 ways to arrange that. Now, why did I put the single here and not here? Well, because putting the single here, I've already counted that. When I shuffle this tail, one of the shuffles includes putting a single there, so it goes double, 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 single, double, single. So if I put the dot here instead of here, I'm already counting that. But double, double, single, double, that's my start. It's everything up to the second to last double jump. That's going to be my start. And then the tail is everything after that. So how many ways can I arrange 3 doubles and a single, where the last thing in my list has to be a double? Well, I can go double, single, double, double, or I can go single, double, double, double. And then, of course, the last 2 things at the end are going to be a single and a double that can be shuffled one way or the other. So I have my 3 ways to arrange 3 doubles and then whatever's left. I have 6 ways to go, well, I have 2 ways to go double, double, single, double, and then whatever's left. I have 2 ways to go double, single, double, double, and whatever's left. And 2 ways to go single, double, 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 and whatever's left. So then I have one more combination to worry about. I might go double, double, single, single, double, and a double. How many ways? Oh, there's more than one way of arranging this. But I can go, this is, how many ways can I rearrange this where I have both of my singles coming before my third double? So I have double, single, double, single, double. I have double, single, single, double, double. I have single, double, double, single, double. I have single, double, single, double, double. Make these rounder so they look like dots. Let's see. And of course, all of these are going to have doubles at the end, which there are only one way of arranging these. Because there's nothing to change places with in the tail on these. So let's see. 2 together in the third. Okay, so there's a hole here, a hole here, and a hole here. So 2 together in the third hole, 2 together in the second hole, 2 together in the first hole. All holes but the first filled, all holes but the second filled, and all holes but the third filled. Oh, that's this one, yes. Dot, dash, dot, dash, dash. So, yeah, those are the only ways that they can happen. You can either stick both of them in the same hole, and there are 3 ways to do that. Or you can put them in different holes, and there are 3 ways to miss one of the holes. So we have, how many do we have here? 1, 2, 3, 4, 5, 6 ways to do that. Okay, so the number of ways to have 4 are going to be 1, 2, 3, plus 6 is 9, plus 6 more is 15. So there the number of ways to have 4 double jumps, there are 15 of them. Okay, so let's do the 2 case now. Since usually the end cases are the easy ones, so notice 1 and 9 and 1 and 15. That's not so bad. The middle 2 cases will probably be the hard ones, so I'm guessing that they'll be I don't know, maybe like 20 in each of these last, the 2 and the 3 case. So let's see. We have 2 double jumps. So how can we arrange that? Well, we can do double, double, and that's 4 stairs. So 1, 2, 3, 4, 5, 6. That's 10 stairs total. Okay, so here is our tail. There are going to be, since there are 6 dots, there are 7 ways to rearrange those. And we can do dot, dash, and then there are 1, 2, 3, 4, 5 ways to arrange those. So there are going to be 6 there. We have dot, dot, dash. And I can't put, again, for the same reason, I can't put the dots here at the end of this initial segment, at the end of the start, because that just puts them in the tail. Remember, the tail is, we find our second to last double, and everything before that's the start, everything after that's the tail. So since there are only 2 double jumps here, the first double jump is the last thing in the tail. So we can have a tail that has all 6 of the singles, or we can have a tail that has 5 of the singles, or we can have a tail that has 4 of the singles, all the way down to a tail that has none of the singles. So as you can see, it's going to be, there are 7 ways to arrange 6 singles. There are 6 ways to arrange 5 singles and a double. There are 5 ways to arrange 4 singles and a double, so on down to 1, 2, 3, 4, 5, 6, double, double. There's 1 way to arrange a tail that has no singles in it. Okay, so 7 plus 6 plus 5 all the way down to 1. There's a formula for this. It's when you're adding all of the numbers, by numbers I mean all natural numbers, starting at some natural number going down to 1. The number you start with times 1 more than the number you start with over 2 is going to be the sum. So I'll state that with no proof. You can practice it. 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 if you want to. You can try that. So I'm going to cancel out a 2 here, so I get 7 times 4, which is 28. So there are 28 ways to have 2 double jumps. And then 3. 3 double jumps will be the hard case, most likely. You can have double, double, double. That's 6 stairs, 7, 8, 9, 10. So there's our start and our tail. There are going to be 5 ways to rearrange this. We have double, single, double, double, 1, 2, 3. There are 4 ways to arrange that, but we also have to have single, double, 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 single, single, single. There are 4 ways to arrange that as well. So we can have the dot come first or second. We can have double, dot, dot, double, which could also come in the form of dot, double, or dot, dot, double, double. As our initial segments, we have a dot and 2 singles, a dash and 2 singles here. So there are 3 ways to arrange that, and that, and that. Yep. And then we have dash, dot, 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 dash, dash, dot. There are 2 ways to arrange that. And how many ways are there to arrange this? We have dot, dash, dot, dot, dash. We have dot, dot, dash, dot, dash. And we have dot, 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 dash, dash up here. And again, there's always just a dash and a dot down here, which can be arranged 2 ways in each of these cases. And then we have dot, 1, 2, 3, 4, dash, dot, 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 dash, dash. There's only 1 way to arrange that. But up on the top we have, let's see. Well, there are going to be, I guess, 5 ways to arrange that, right? 1, 2. Yeah, let's see. That should be all the ways to arrange those. So we have 1, 2, 3. Yeah, 5 ways to arrange those. And the tail, of course, is just a single dash by itself. And that should be all the ways to do this. So let's see. We have 5 plus 8 is 13. I don't want to mess up on this, so let's see. 1, 2, 3. There are 5 here and 5 there, so let's cancel those and give us a 10. There are 8 here. Let's cancel that and that to give us a 10. And let's cancel that and that to give us a 10. And we have 5 left over. So it looks like we have 35. So let's see. 1 plus 9 is 10. That looks gross. Let's see. 35 and 15 is 50. And 28 and 1 is 29. So does that make 89? Is that right? That's I think that's right. 89 is a weird number. Anyway, so that should solve the problem. I hope I didn't make any mistakes with that, but I don't think I did. Anyway, have a great day and see you next time. Bye.